Hey there, year 12s. We're now doing activity question 4. So question 4 here, we're looking at again forward scanning, backward scanning, critical pathways. So what do we have here? An activity network is shown in the diagram below. Q, write down the critical path for this project. So hopefully up until this point, we know that the critical path is which of these activities, okay, cannot afford to, I guess, have wiggle room. And hopefully what you can see here in question 4, I can see that clearly we're starting off at the same point, which is 0, 0. Now, out of them all, if I went through path A, notice there's wiggle room. It can start at 3 or it can start at 4. So that means there's some float time there. So that's not a critical path. Whereas part D, activity D, you can see that it starts at 12 and it can only start at 12. Earliest and latest is 12. So it means it's a critical activity that if D doesn't do it in 12, it's a problem, okay? Because it takes duration of 12 and it has to be done in 12. And then you look at the next one, you might question, well, actually this point over here, which is the starting of F, has 22, 22. You're wondering, should I highlight C? No, you do not highlight C at this point because clearly we've identified that D will give us that 12 and 12. Now you're wondering why couldn't I have done it this way? Because the duration, can you see the duration of C is 7. If this is 0, 0 plus 7 doesn't give you 22. There's no way you could have got 22 from activity C. It must then have to be the fact that you went 12 here and then 10 there. So D and E adds to 22. Meaning that, remember, you're always accounting for the largest value when it comes to earliest starting time. So EST, yeah? So for EST, you account for the largest value. So clearly, E then becomes a critical path that E cannot screw up. E starting point is 12, and then starting point for E is also 12. So clearly, E is a critical path, and then F is also a critical path there. So that's why I know the critical pathway for this project is D, E, and F. It also means that if C only takes 7 units, well then clearly 22 take away 7, they can start at latest at 15. So if you draw a box here, latest could be 15 and earliest start time could be 0. Okay, so they can start at 0 if they wanted to and they'll finish in 7 minutes, or they can start at 15 and still finish on 22 minutes and it doesn't delay anything else in the entire network. That's the idea. Okay. Now I've got my C. Actually, I'll just move on. Calculate the float times for non-critical activities. So what are non-critical activities? Non-critical activities, there's only 3 activities I haven't accounted for. Activity C, activity B, and activity A. Your job is to find the float time. So float time for activity A, you can see that the earliest start time is clearly 0, but notice that it's a duration of 1. Duration of 3, and you know that earliest start time is 3 and latest start time for the next activity is 4. So technically, you don't have to start at 0. Technically, you could also start at 1. Okay, so keep in mind that the number, why is it 0, 0, is because out of them all, you choose the smallest value for backwards scanning, so latest starting time. And so technically there should have been another box here for A. This is the box for D, and then there should have been another box for C, but you always choose the best one. So in this case here, you could have started at 0, or you could start at 1 and you will still finish on time for activity B to continue and without screwing anything else up. Okay, so that implies to me that what is their float time? Well, clearly 0 and 1, there's a distance of 1. So float time for A is already 1 minus 0, which is 1. What is the float time for B? Okay, so for B, again, you can start at 3 or you can start at 4, and therefore you can say then 4 take away 3 is also 1. So you got a 1 of flexibility there. And then what's the other one? Activity C. So again, if you try to picture activity C, you could start off earliest is 0, but remember, like I said, 22 take away 7, that means they could have started at 15 and still finish at 22. So that's a massive float time, isn't it? There's a 0 to 15, so the float time there is 15. Okay, 15 units in between. So float C is then 15 units. Okay, so that's how I would have done. Is there another?